Okay, so we're going to focus mostly on compositions today. Okay, so one thing I want to remind you is if I have a function, okay, and let's say that f of x is x plus 2, just a simple function. And then I ask you to evaluate the function for f of 2. What are you going to do? Where are you going to put a 2? I shouldn't have used a 2. Let's not use a 2. Let's use a 3. So, yeah, we're going to take a 3 and we're just going to plug it in for x, right? That's it. So the function, the value of f of x when x equals 3, in this case would be 5, right? Okay. We can do that on a bigger, larger scale. Okay. It's not always going to just have to be a single number. Okay. It could be 3x. So if I put 3x in there, then all that's going to change it would be 3x plus 2. Right? I could make this 3x plus 1. And then everywhere that we see x, we have to put 3x plus 1 in. Well, now I would have to combine like terms, right? So it would be 3x plus 3. Okay? So what we put inside of these parentheses for a function determines what our x value is, right? And what we plug in, what our input is. That's really what we're going to build off of today. Okay? So remember yesterday, we started with adding functions, subtracting functions, all of our operations with functions. So for this one, I would take the f function, which I'm going to use red for, and it would be x squared minus 3x, and I'm going to add it to my g function, which is 4x plus 5. Okay? Because there's nothing for me to distribute here, that's a plus sign between the two binomials. I don't have anything to distribute. I'm just going to combine like terms. So that's going to give me x squared minus x plus 5. So now, like we just talked about, if we want to evaluate this function for when x is 2, where am I going to put the 2? I'm going to put the 2 everywhere that I see an x, right? So it's going to be 2 squared minus 2 plus 5. Okay, I'm going to get in the habit of, and I think it's a good thing for you, to always put that in parentheses, because when it's a negative, it's going to matter. Okay? So now 2 squared is 4 minus 2 plus 5 equals 4 minus 2 is 2, plus 5 is 7. Yeah. Okay, so this combined function when x is 2 equals 7. Okay, this is what we're going to spend most of our time on today. All right, sometimes this is going to be a bracket, sometimes a parenthesis, but we read that as f compose g. Okay, this right here is the way your book is going to show it most of the time. Okay. I don't really like that way. I like this way a lot better. Okay, because it really shows that we are taking the g of x, our function g, and we are putting it inside of the function for f, right? That's really what we are doing. All right? This graphic down here is something I want you to add to your notes. Okay, a is x without us doing anything to it at all. It hasn't been multiplied, it hasn't been squared, it hasn't been added to or subtracted to. It's just x. Okay? Then, that B oval, f of x, we've applied one of our functions. We've applied function f, right? And then the last one, that oval C, we've now applied a second function. So it's a function on top of a function. So on the bottom there, it looks like GOF, G-O-F, right? That's G of X, right? Okay, that O, okay, that's G of F, not X, sorry, G of S. This open O, that's the symbol for composition. G compose F. Okay, that is not an O, that is not G of, it is G compose F. Okay, that's something that we need to make light of here, is that this symbol up here, oops, has an open circle, right? What if it was a closed circle like this? Then what would it be? That's multiplication, right? An open circle indicates composition. Okay? We all good on just how we're going to write things out and communicate about it? Okay, you're going to hear me say f of g of x or g of f of x or whatever letters we're using. Okay? Talking about domain. Again, this is not in your notes. Yesterday we talked about domain for most of these is going to be negative infinity, infinity, unless it's division. Because division, we cannot have a 0 in the denominator. We cannot have a 0 in the denominator, okay? With composition, the domain is going to be all the x values of g of x and f of g of x, okay? So it's like the overlap, okay? Again, most of the time it's going to be probably negative infinity, infinity, unless there's division somewhere in there and you have a variable in the denominator. Then we'll have a limiting factor, x cannot equal blank. Okay, so here's an example of what we're going to do. We have our two functions up here at the top. I like to highlight these just to kind of set them apart. Okay, and then this first one we're going to do right here is f compose g of 3. Okay, now if I want to write this in the other notation that I like better, it would be f of g of 3. And that's what we're going to find. Okay, because they're telling us x is 3, we're going to find a value. One big thing here is we have to work from the inside out. Okay, so we have to start on the inside of this right here and then figure out what g of the value is for g of 3 first, and then move our way out. So we go inside out. So I'm going to take this 3 right here and plug it in where? Where am I going to plug it in? Which function? Yeah, g of, so I'm going to take a 3 and plug it in there and there. That's where we're going to start because it's the g of x first. We start inside out. So all I'm going to do is replace the x with a 3. So I've got 3 squared plus 3 times 3 plus 4. Three squared is 9 plus 9 plus 4 equals 22. Now that g of 3, we know that the function of g when x is 3, we know now that it's equal to 22, right? So now that 22, I'm going to take that, and we can put it right here instead of g of 3 because I know how much it equals. Okay, and I'm going to just rewrite that down here now. So f of, now I'm going to think about my f of 22, because I know g of 3 is 22, equals, and now we're going to plug 22 everywhere that we have the x. So 3 times 22 minus 8. Three times 22 is 66 minus 8 is 54. What? Yeah, it is 58. 58, not 54. Thanks. All right, now I want you to do the next one. One thing I want you to notice about this is instead of it being f of g, it's g of f. So things are backwards. Okay, so watch this first. G is going to be on the outside of f of -2. So now we have to go plug this -2 into f first, into the red one first. Then we plug it into the g. Okay, give it a try. All right, so I'm going to plug this into my f function first. So we're going to take the -2 and plug it in right there. So f of -2 equals 3 times -2 minus 8, which is going to be equal to -6 minus 8 is -14. So now I know that the function of x when x is -2 is -14. So now for f of -2, I'm going to substitute -14 in. So now g of -14 equals -14 squared. That's why it's important to put it in parentheses. Plus 3 times 14 plus 4. What's -14 squared? It's going to be positive 196 because it's a negative times a negative. Plus 3 times 14, 42, plus 4. And this, I did that again. That should be a -42 because that's supposed to be a -14. Okay, so 196 plus 4 is going to give me 200 minus 42 equals 158 is our value. Okay, so it's really step by step by step. Put it into the first function, then you put it into the next one. The key is starting inside and working your way out. Okay, or if you're looking at this method right here, you actually go from right to left. You take care of the first one first on the right, so G, and then move to the end. Okay? I want you to look at these bottom two. We're not going to do these. We're not going to actually do all the math, but look at these two down here. I want you to compare and contrast them. What's the same? What's different? Five, 4, 3, 2, 1, 0. All right, Blaze, here's the softball. Ready? What's the same? They both have 5. Yeah, the x value on both of these is 5. Okay, what's different? What's the thing that's different, Alice?
They're switched around, so the numbers are just switched.
Yeah, they're switched. So this is f of g, or f compose g. This one's g compose f. Okay, my question to you, and I want you to talk to a neighbor about, do you think these will yield the same answer? Go. Does anybody think that they're going to be the same? Nobody? Okay. You're right, they're not going to be the same. Okay, the majority is correct there. All right, let's talk about a little about y. I'm not going to do all the math, but let's look at y. If we have to do, I'm going to do the second one. Let's look at this one right here. If I plug 5 in for x up here, what's 3 times 5? 15 minus 8 is 7, right? Then we take 7 and we plug it in over here. 7 squared is 49, plus 21, plus 4 is going to give me a 74. Okay? If I go the other way and I start here, 5 squared is 25 plus 15, okay, which is going to be 40, plus 4 is 44. if I put 44 into the red function, 3 times 44, that's going to be like over 120. That's going to be way too big right away, right? It's not going to give us the same thing. So what I want you to write down with this is put an arrow next to these like this and write will not be equal. I don't want you to just assume that if they switch around the letters that it's going to be the same thing. I don't need to do the math. All right. Now, what's different about this one compared to what we just did? The functions are different. Are they? I think they are. Yeah, they're different. But what else is different? There's not a number for x. It's just an x, right? Can we do it? Remember we talked about at the very beginning? We can put anything we want in there for x, right? And we just substitute it for what? For x. Okay? So, here's how this would look. Like that. I prefer this one, again, because you can see that we're working inside out. Okay? So what this means is that I have this value, g of x, that we're going to actually replace x for f of x. So I'm going to take this whole thing, which is my g of x, right? And I'm going to put it right here in place of that x. So then the way this would look is f of g of x equals, I'm going to put my 2, but then I've got my g of x value, so x squared plus x minus 1, and then plus 3. So all I did was replace the x with my g of x function. Now what do I need to do with that 2? Distribute it. 2 times x squared is 2x squared. 2 times x is a 2x. 2 times negative 1, negative 2, and then we have the plus 3 still. Is there anything I can combine? 2 and the 3. So 2x squared plus 2x plus 1. So f of g of x equals 2x squared plus 2x plus 1. Or f composed g of x equals 2x squared plus 2x plus 1. This is going to be the same thing. We're going to start with the one on the left right here. Okay, they just give you 3 functions to work with. You're only going to work with 2 at a time for now. So this first one, we're still going to work with the f of x and g of x. Okay, so I want you to try this for that first one that I highlighted in yellow. So it's going to be f of g of x. Taking the g of x, and we're putting it in place of x. So what we have here is we've taken our function g of x and we've plugged it into f of x in place of x. So this is what we have. Hey, is there anything for me to distribute? No. Okay, if we would have had like a 2 right here, then there would be, but we don't. So all we can do now is combine like terms. So f of g of x equals, is there any other x squareds to combine with? Nope. So I've got x squared plus 2x, and then positive 3, negative 5 gives me a minus 2. Okay, let's try the second one. Okay, now you're going to be using the purple and the green. That's what it should look like as you set it up. We're going to pause now and let you finish it. So we're going to distribute our 3. Just like that. Okay, so far we've done compositions with 2 functions. Okay? We can do compositions with 3 functions. We're going to start that tomorrow. Okay? So for tonight, we're not going to have any homework because the homework is going to include some of the compositions with 3 functions. But here we go. You remember this from yesterday?
Yes.
This is where we left off yesterday. Okay? F of x was red, g of x is green, h of x is purple. We are talking about putting functions inside of functions is what we're doing. Okay? So remember, compositions of functions is when we were taking a function and putting it into another one. So the last one we did was this right here. Okay? We were doing the h of g of x, right? So you can literally see right here that we put g of x inside our function for h, right? So we're taking x squared plus 2x plus 3, and we're putting it in for x. Okay? Now, if there was another x here, like this, we'd have to do it in both spots. Okay? That's going to come up on your homework today. Okay? But there's not. So we only did it in one spot. Then we have to distribute the 3. So we distribute the 3, boop, boop, boop. We end up with 3x squared plus 6x plus 9. We good on that? Okay, just kind of catching back up where we were at yesterday. Okay, now we have hog off, okay, which is h compose g compose f of 2. Okay, so this is the h of g of f of 2. Okay? If we were to write it into the other form, it's h of g of f of 2, like that. It's a lot. Okay, remember that we start from the inside and work out, right? So the first thing that we have to do is figure out this part right here, f of 2. So what am I going to do with that 2? Yeah, I'm going to go put it in the x spot for my f function. So I'm going to take f of 2 equals, I'm going to put my 2 right here, minus 5. Get in the habit of putting it in parentheses when you plug it in. Just get in the habit of doing that. Sometimes it's not going to matter, but sometimes it really is going to matter. 2 minus 5 is negative 3. So now we figured out that that yellow spot right there, f of 2, is actually negative 3. So watch the screen here. This is what actually just happened. F of 2 is no longer a thing. We just turned it into negative 3. So now we've got to go and do g of negative 3 because that's what f of equals. So now I'm going to do negative 3. This is where that parenthesis thing really matters. Plug it in there. We do the math. Negative 3 squared is 9. 2 times negative 3 is negative 6. And then plus 3 is going to give me 6. So now we know that the g of negative 3 is 6. So again, what we just did is, all right, that's gone now. Now we know that the g of negative 3 is actually 6. So now there's a 6 in here. So now we're going to take that 6 and plug it into what? Into what? H. So now I go grab my H. But it's going to be the H of 6 equals 3 times 6, which is 18. Step by step by step. First this, then finally that. That's how you have to do it. Okay, in this case, we use 3 different functions, right? Do you think we could have gone h of g of h? Could we plug it into h, and then plug it into g, and then plug it back into h? Is that conceivable? Yeah, you can absolutely do that. Okay, really, like I think we could probably do h of h of h of, like if you really want to do something like that. I don't know what realistic purpose that would be, but you could. Okay. So now this is what you're going to do in your notes. It looks a little bit different on yours. Okay, on yours it's spread out. You have one on the left and one on the right. The brackets do not matter. Okay, it's still the same thing. So we have f compose g of x, which is actually f of g of x, right? And then you have g compose f of x, which is g of f of x. Okay, so I want you to try this on your own in your notes. One is f of g of x, the other is g of f of x. Okay? You have your 2 functions at the top. We'll still use the same colors. Okay, on the first one on the left, I'm putting g of x into f of x. So I'm taking this right here, and we are putting it into here. So it's going to look like this. Okay, the f of g of x is equal to, I'm going to do my red first, 2, and now I've got to plug in my 3x instead of my x, and then minus 5. Now I'm just doing 2 times 3x. So that gives me 6x minus 5. So f of g of x equals that. Okay, now the other one is similar, but different, because we're doing the opposite. I am taking my red one and plugging it into my green one. So I'm going to start with my green. G of f of x. And we're going to go 3, but instead of x, I'm going to put 2x minus 5. Now we distribute. G of f of x equals 6x minus 15. They are similar, but not the same. Okay, that is it for today. Your homework is going to be a worksheet that has both operations and compositions. Okay, remember, composition is going to look like this. F, open circle, G of x, right? That's a comp. Okay, an operation, like for multiplication, is going to look like this with a closed dot. of x, or sometimes it's just they squeeze them together like that. Okay? That's for multiplication. This is what we did on 6.1, day 1.